Good afternoon. I'm so sorry I couldn't be with everybody in person today. I'm actually doing another session on the core curriculum right now. So my fellow presenters have graciously allowed me to do a voiceover video to talk to you about the wellness check. I'm going to keep this really, really short. If you do have questions about the wellness check, you can always send them in my direction and I'll try and answer those specifically. But the short version is I get a lot of questions about how are we using the general ed core assessment data other than just to improve a single course's teaching. And obviously that's a magnificent goal in and of itself. But we're also using that information or have used that information for what is called the core curriculum wellness check. And it was conducted in fall 2019 using the cycle 1 and cycle 2 results. It was conducted by members of the curriculum committee, the curriculum office, and of course retention, accreditation, and planning. We looked not only at the results of the cycle assessments, but also enrollment, assessment approaches, class distributions, all of those sorts of things. Now, one of the things that we needed to do for the core curriculum wellness check was code different types of assessments into categories because we have a very diverse approach to our core curriculum assessment. And so there are 6 learning outcomes, and each course is usually assigned 4 for each course that's in the core curriculum. Some of these courses are assigned the empirical and quantitative learning outcome, and that outcome asks for reflection not only on quantitative reasoning, but also using that to form a line of inquiry and answer questions. So inside of our empirical and quantitative assessment, there's a number of different approaches. Some look at experiments, some look at answering scientific method questions, some look at actually solving mathematical problems. And so these different types of assessments were all coded so that they would be compared only to each other of the same type. And in doing this, we were able to have a revelation that when our students were asked to do computational math for a learning assessment, that they were not performing at the same level as the other empirical and quantitative outcome. So this is a brief table that breaks down the results for the empirical and quantitative coding. If you look in the column on the far left, it's going to show you the 3 types of assessment that were conducted. So 19 courses that assessed empirical and quantitative as a learning outcome had students conduct some kind of data analysis. 13 courses that assessed empirical and quantitative had students engage in some kind of computational activity. So this is where they're actually having to complete a setup and complete a math problem. And 7 courses in the empirical and quantitative area actually had students set up and conduct an experiment of some sort. Now, once we have a course that is assessing in an area, they get to adopt their own standard. And what the rest of these columns are showing you is how successful were these courses in achieving their standards. So if you look across the data analysis row, what you're going to see is that 19 courses assessed that area and 19 were able to meet the standard that they set for themselves. Absolutely no course that asked students to engage in data analysis failed to meet their standard. And so from there we conclude that our students seem to be doing quite well in demonstrating data analysis abilities. If you skip all the way down to the bottom, you'll see a really similar trend for conducting an experiment. If we have students that are called upon to work out a line of inquiry and conduct an experiment, absolutely all of the courses that assessed in this area were able to meet their standard. But the interesting one comes in the computational abilities area. So if you look, we have 13 courses that are assessing computational abilities, but only 8 of them were able to meet that standard. And spoiler alert, the ones that were able to meet the standard come much later in the student's experience. These are mostly physics courses that require students to have higher order math before they can even get into the course. And so while it's good that a student can engage over time and develop those skills, what we are seeming to see is that students that have not had that level of contact and experience with computational math are not being as successful in meeting the standard. And that's really why we're engaging in this process, is we would like students to be able to do what our calculus students can do. and that is to be able to handle simple mathematical equations and solve math problems. In having our conversations with many disciplines from across the college, we've come to realize how important computational math is to many, 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 if not all of our disciplines. But in many of our pathways, students will only have a singular experience with computational math, and that's when they take whatever the required math course is. So what we're hoping is that we can learn from our assessment to say that more math experience helps. And even though that seems obvious, it isn't necessarily how our programs are set up. And our plea today is for you as an instructor to add math to your process in your course as a talking point so that we can continue to develop that experience level in our students. That said, the goals for this team are pretty straightforward. What we're really hoping is that we're able to accomplish three things. One, we're looking for information related to how and where computational math is taught across our programs and disciplines. Now, for that, we are going to be doing some surveys. None of that will have to be administered by you as a faculty member, but definitely look for more information coming soon because we'll need your help in advertising it for your students. We're also trying to understand students as whole learners, specifically by looking at the impact of socioeconomic factors that may be impacting their performance. Examples of this could be anxiety that they have about math. So maybe them being nervous when they know they're being tested is keeping them from performing at the level that they could. Also, maybe a perception of their own ability to do math. So anecdotal evidence we've gathered so far has told us that a lot of our students just believe that they quote unquote can't do math. And as a result, they're not even really feeling empowered to learn or try. It's simply a piece of themselves they've decided is already impossible. That's part of that same survey that's coming soon. We're also really interested in engaging faculty and every part of the institution about where and how we are learning computational math and where we need students to know computational math. So that way we can enhance these opportunities where students encounter math throughout their educational journey. Hopefully that encourages them to transfer skills from classes and not simply learn some math for a test and then move on. Overall, our big goal is to work toward assuring that every student that completes their education at EPCC is able to complete simple arithmetic computations without needing something like a calculator, and that all students are able to understand how to set up whatever higher order mathematical computations that they need, even if they need to use a calculator or a spreadsheet to complete those computations.